We're going to take a pretty quick look back at factoring. Factoring those polynomials. Now, I'm sure you've had this before. It should have been a major focus of Algebra 1. So again, it's going to go pretty quick, but I hope you remember how to do this. So the first thing we need to do is remember a greatest common factor. So that isn't something they all share. We want the largest number in a sense that you could divide out of all of these terms. So I have three terms, 1, 2, 3. So first of all, I would just start with the numbers. What is the largest number that could divide into each of these? Now 6 is pretty limited. It's made up of only 2 and 3. So I can either divide 6 into all of them, or maybe I could divide 2 or 3. Now 6 isn't going to work because this is 45 here. So I'm going to try 3. I can pull out a 3. Now if I pull out a 3, I'd be left with a 2 there. What would I have here? I'd have 15 and 7. Now I would do all these probably the whole thing one at a time, but just to show you the idea. So I'm checking the numbers for the largest thing I could divide into each of them. Now there's 3. Now how about the x's? What is the largest number of x's they share? Well, they just share 1. That's the most that they share throughout here. So I'm essentially dividing them out. So I took all the x's from the last term, so there's none left. Now how about the y's? Well, the largest number that they all share is simply 1. So I could take out 1. Now if I'm dividing him out, that only leaves 2 left on the first one, 1 on the second, and none on the third. Now make sure I put those signs back in. So that's a positive 15 and a positive 7, but because it was addition or subtraction, I'm going to show it there as a plus sign. Now that is a real fast overview of how you do this. Again, if you want some more, I've got other videos like that in Algebra 1 videos that treat this a little more extensively. Okay, so this one is a crazy way to do. They're right about this, but this is a little weird. B squared minus A is all a number. Because it's in parentheses and connected by the negative, this is a match. And so I know where they're going with this, but it's kind of a weird one we haven't practiced. This is your GCF. This is the number they share. So x times this number, 6 times this number, I don't know what that thing is, but it is the GCF. So you could pull that out and you leave behind the x plus 6. So I'm factoring him out. I'm dividing him out. He'd go in the front, and what would be left behind is x plus 6. Okay, now do you remember how to do these? Now we're going to see that these get a little harder when there's something in front of the x squared in the front. But when there is not, what you're doing here is I'm looking for two numbers that multiply to make negative 5 and add to get 2. So I would always start like this. I know the x squareds are going to just be x and x. Okay, I'm going to make these two factors. Now what are the two numbers that multiply to get negative 15 and add to get positive 2? Now it's going to get harder in a minute, but I would show them over here. What this tells me is because it's negative 15 and I have to multiply, it has to be numbers with two different signs. So it's positive 5 and negative 3. Now once I've found those, I can just put those numbers in here, positive 5 and negative 3. Okay, so once again, this is the easier version because there's nothing in front of that x squared. So I'm going to bring that 6 over here. I'm looking for two numbers that multiply to get 6 and add to get negative 7. Now if you do a little Sherlock Holmes logic here, if it's positive 6, the numbers have to have the same sign. And if they have to have the same sign and have to be negative 7, it's going to be two negative numbers. And you agree these are the two. If I multiply those, I get positive 6. If I add them, I get negative 7. Okay, this gets a lot of different names, and they're calling this grouping here. I prefer a name called the AC method. It's the same thing. What they're saying is I have something in front of the x squared now, so it is not as simple as just putting x times x. Because if I FOIL that out, that's not going to create the 5 in the front. Now there's a method where you can just kind of guess your way through this, but I'm going to show you, I think when they call grouping, they're referring to this, what I call the AC method. It's called the AC method because I'm going to take this A, this term in the front, and the C, which is the term at the back. I'm going to multiply those together, and I get negative 30. Okay, now I'm going to so I'm going to write this number over here. I'm going to do the same game that I did before. I need two numbers that multiply to get negative 30 and add to get this middle. Now, what would those be? So I've got a negative, so I'm going to have two different signs. One's going to have to be a positive, and one's going to have to be a negative. Do you see that these would be my two numbers? Okay, now we're not done. It's not as simple as x plus 10, x minus 3 because of the 5. So what I'm going to do is I'm going to turn those two numbers I found into the middle. I'm going to do this. You see, I haven't cheated because if I put them back together, it would be 7. But I found these numbers because they allow the factoring to fall into place. Now, here's the last step. You have 4 pieces now. Take the GCF of the first two and the GCF of the back two. Now, the front end here, you could take out a 5x. On the back end, it's 3. The number they share is 3. But if it starts with a negative, take a negative. I want to make that negative 3. Now, when you factor that out, because you took a negative, it's going to change the signs of everyone who follows. Okay, now this is why they did that try-it where they had this, the GCF is x plus 2. So if you thought of this right, the GCF here really is x plus 2, so you could pull that out, and what you would leave behind is 5x minus 3. That's why it works. But if you just want to know what to do, the match becomes 1, and everything else goes together to make the other. So I would refer to that as the AC method. Okay, they've given us a couple of these to try. So pause it if you want to try on your own, especially if you're rusty on this. But so I'm going to do the AC method here because I have the 2 in front. So 2 times 9 is 18. Okay, I need two numbers that multiply to get 18 and add to get positive 9. Now can you see that's going to be plus 6 and plus 3. So I'm going to turn those into the middle like this. And the reason I did it is it's like a factoring magic trick. It's going to allow me to pull the GCF of the front two and the back two, and everything should fall into place. On the back end, I would take a 3. Now I've got my match, so that's one of them. It's really what you're doing is you're pulling out a GCF of x plus 3. Okay, and that would be factored. Don't stop at this step. Students will do that and think, hey, I'm done. Or what they'll do is they'll factor down like 2x plus 3s. That's not it. You're pulling out the x plus 3 as a GCF, and this is what it would leave you. Okay, we'll try another one here. I can't just simply play the easy game because I've got the 6 in the front. So I'm going to do 6 times negative 1 is negative 6. Now I need two numbers that multiply to get negative 6 and add to get positive 1. Well, those are going to be positive 3 and negative 2. So I'm going to make these now into the middle. And interestingly, it doesn't matter which order you would do them, and it will work either way. Okay. So GCF of the first two, GCF of the back. Now this, you can't just take 3x and leave nothing there. If you divide away 3x, it's going to leave a 1. Now on the back end, there doesn't appear to be anything to take. So you always have to take something. So I'm going to take a 1. But because this started with a negative, I'm going to take a negative 1. Oh, I'm sorry. Whoops. I messed this up. Do you see? I should have had a 2x there. It's a negative 1. Now if you take a negative 1, it'll change all the signs. Now I caught that I had messed up earlier because I knew these had to be a match, and I wasn't getting a match. I said, what did I do wrong? So it has to be a match. Now the match becomes 1 because you're pulling it out like a GCF. Everything else becomes the other. All right, now we saw some, in the last video I think, we saw some patterns for multiplying out the binomials, and we saw this special one. We saw that if we did this, what we could do is square the front, square the back, and then 2 times 5x, and you'd get 2 of those. Well, we're going to undo that pattern. The reason that pattern is so helpful is that we can sometimes factor and find that we could do this in reverse. So here's how you would check. You'd say, hey, do I have a square root on the front? I do. 25x squared as a square root is 5x. I'm going to write that twice. Okay, does 4 have a square root? Yeah, it does. It's 2 and 2. I'm going to write that twice. Okay, now is the middle, this 20x, is it 2 of these guys times each other? So here's what I mean. Is this 2 times 5x? It'd be 10x. Is it 2 of them? It is. Yeah, it's 20x. That's 2 of them. And so this right here is that special factoring pattern just going the other way. So instead of multiplying it, we're breaking it down, and we saw that it fit the pattern in reverse. And so I would get this. Now, if you were questioning the sign, if you fit the pattern with the square roots on the front and the back, and you have that double in the middle, it's the sign for these are both going to be the positive there. So let's see if they gave us another one to talk through. So here's what I would do. I would check for a square root on the front and the back. I have it, so I'm going to write those square roots. Now, is this middle 2 of these? 2 of 7x times 1. Yeah, it is. 7x, 2 of them would be 14x. It is. Now, the only thing left to do is we need the sign. If this was a positive and we fit the pattern, it's going to be 2 of the sign in the middle. It's going to be 2 negatives. So it has to be negatives in order to create negative 14x. Okay, now we saw another pattern where we had this. 3x minus 5, 3x plus 5. Okay, if we FOILed this out, we saw the middle always disappeared. Well, look, this has no middle. So we saw the middle disappeared and it would always be a negative. Well, I think we have this the other way around. So let's try it. What I would do is I would check for square roots on the front and the back. And I have them. Now, if there's no middle, then it must have meant that it had opposite signs, so the middle fell out. Now, just one word of caution. If you look and you say, hey, I think this fits the pattern, I have the square roots on the front and the back, and there's a positive in between them, be careful. That actually will not factor. There's no way to create that, and we could spend some time trying to look and see why, but it can't be done. So the only way you can factor it is if it was a negative in between there. So if I'm looking at this, I see a square root on the front. I'm going to write it twice. I've got a square root on the back. I'm going to write it twice. It had the negative in the middle, so this fits the pattern. One of them's a minus, one of them's a plus. Okay, now that's very quick. I have much longer versions of this discussion from my Algebra 1 section.